Hello and welcome to coDiagnostiX video training. In this tutorial, I'll cover the complete digital workflow in coDiagnostiX. I'll only give you a brief overview though. Refer to our in-depth videos for further details. First of all, we need a CT or CBCT scan, as well as a surface scan of the patient. Let's start with importing the Dicom data. Normally, you'll load the data from your CD or DVD drive, or from a USB flash drive. In this particular case though, the Dicom data are stored on my hard disk. Now we check the patient information extracted from the Dicom data and correct the information if necessary. coDiagnostiX opens the patient automatically and sets up a new plan. Here we're dealing with a mandible case. OK. The toolbar lists all required workflow steps. Let's go through them step by step. First of all, we added the panoramic curve, which defines the panoramic view and the virtual OPG. I scroll to a suitable plane in the jaw and indicate the incisal point and the positions of the third molars. Then I try to reproduce the shape of the dental arch using the other two control points. Next up is importing the surface scan. First, we choose the surface scan to be imported. To align the surface scan to the volume data, we use anatomical landmarks. Generally, these will be placed on a segmentation of the dental crowns. So, let's create that segmentation. We use a segmentation threshold between 1000 and 1200 Hounsfield, because in this range the teeth are clearly visible. Turn on segmentation mode, select an empty segmentation, and assign a name to it. To simplify matters for us, let's insert a segmentation boundary. Then we segment the mandibular teeth. After that, we remove the tooth setup as it isn't contained in the surface scan. That'll do. Now we can select the segmentation we just created. In both views we place pairs of points that correspond to each other anatomically. At least 3 point pairs are required, although more landmarks generally yield more reliable results. With the help of the landmarks, coDiagnostiX computes an optimal matching, which we'll review now. Scroll through the 3 2D views and check for proper alignment. For corrections, I suggest the Fine Alignment dialog. Here we can change the alignment in small, controlled steps. Anyway, I think I'm content with the alignment and accept the result. Now let's detect the mandibular nerve canals. In this example, only the right one is of interest to us. One end point of the mandibular nerve at the mantle foramen can easily be set in the 3D view. Let's detect the rest of the nerve canal in the cross-sectional and tangential views. When all the preparatory work is done, we can go about planning the implants. Choose an implant model and mark the tooth positions where the implants should be inserted. Implant length and diameter can easily be changed later on. Initially, I coarsely align the implants in the virtual OPG. Yet I can position implants far more precisely in the cross-sectional and tangential views. In this example, the tooth setup, represented by the radiopaque teeth in the CBCT, provides a good indication where to place the implants. There's a couple of other methods to import such a setup for backward planning. It can be imported from a dental CAD system, via a surface scan containing the setup, or via the built-in virtual tooth functionality. Let's insert a tissue-level implant at tooth 4-5. Using these controls, we can quickly change length and diameter within an implant series. We insert the sleeves all at once by selecting the node tooth positions and choosing our desired sleeve system. Here, it's important to verify the sleeve's distance to the gingiva and the neighboring teeth. This is where the surface scan we imported earlier comes in handy. Now that implant planning is done, we can proceed to designing the drill guide. First, we select the surface scan, which will serve as the basis for the drill guide. Then, we set the drill guide's insertion direction to specify how the virtual model should be blocked out. In this step, we define the contact surface and thereby determine the shape of the drill guide. For this purpose, we place spherical objects on the virtual model. Each of them is assigned to a tooth and can be edited in position and diameter. Together, these spheres form the contact surface on the virtual model, highlighted in blue. You can set the drill guide's offset to the contact surface and its wall thickness using these two parameters. To check the drill guide's fit during surgery and to allow for a greater range of motion for the surgical instruments, we cut out a few inspection windows. Finally, you have the option to label the drill guide. This way you can match it to a patient. However, you may also imprint extra information from the surgical protocol. Now the drill guide is being computed. In the last step, you can inspect the drill guide once more. If necessary, you can go back a few steps to adjust some settings. In the producer version of coDiagnostiX, you can proceed from here directly to exporting the drill guide as an STL file. More commonly though, you will just send the final plan via case exchange to your partner, who will then produce the drill guide for you. Finally, we print out the required protocols. In this case, I want the material list, the details and the surgical protocol to be printed. These documents can either be printed directly or saved as PDF files. This wraps up the planning of this case. If you have further questions, I suggest you check out our support webpage at www.coDiagnostiX.com/support. Thank you for watching this tutorial.